Welcome back to Scope News. You're just in time for a weather forecast.
Balloons have so many uses. They're great for a party. We can use them to predict the weather or go on a breathtaking ride. But have you heard of the newest craze called ballooning for bees?
It's our latest research tool and it's helping us learn more about these flying insects for a very important cause. There are over 2,000 species of bees in Australia, but the most popular is the honeybee. Not only are they cute, but they also play an important role in the pollination of crops like lucerne, apple, canola and almonds.
But the bad news is these little guys are under threat from a nasty parasite called the varroa mite. This tiny mite destroys wild honeybee colonies and has been causing big problems overseas. So if it were to end up in Australia, it could cause the loss of all our wild hives. To understand where our current population is, we're sending up this balloon to assess the density of male bees in our area.
So, why the male bees? Well, the male bees, known as drone bees, only have one job, and that's mating with the queen. In the warmer months, tens of thousands of them get together in large swarms to wait for a queen to emerge from her hive.
They're able to locate the queen by smell, so we found a way to use this to our advantage. We begin by filling this weather balloon with helium and then treat the lures with a synthetic pheromone which replicates the smell of the queen. We then let the balloon float up until it's about 10 meters above the ground. The smell of the pheromone attracts the drone bees to the lures, where several of them enter the funnel-shaped trap. Once we have some bees, we pull the balloon down and take them back to the lab.
Drones only inherit their DNA from their mother. So if we have enough drones, we can use their DNA to work out how many queens there are in the area. We do this by extracting their DNA and analysing a selection of their haplotypes. A haplotype is a sequence of short tandem repeats in DNA. These sequences can be made up of a combination of bases which are usually called by their initials A, T, C and G. By comparing their haplotypes, we can then identify the different mums and therefore understand how many queens were involved in producing the drones that we caught.
So far, we found at least 100 wild hives in a radius of about 2 kilometers around our campus, but we still want to do more collections. That way, we'll be able to combine our final number with the known number of managed hives in the area to estimate how much of the pollination is done by wild honeybees. This will tell us what we stand to lose if the mite comes in, which should help us to prepare for this event.
It's a unique way to use a balloon that's helping us learn more about these very useful bees.